Hello and welcome back to the El Diabolo tutorial series. I'm Michael and this is part 5 of our tutorial series. Well, this time around it will be a two-parter, because there's a lot of ground to cover, but basically we will improve our game mechanics. So the first thing I want to talk about is the downside of using a reticule material. And the first thing I want you to do is to actually download my Toot Assets 4 in the tutorial description or in the video description down below. Extract it and import it into our Unreal Engine. Don't select auto generate collision because we don't need any collision, so uncheck it. And in the normal import method, use the import normals and tangents, and then press import. Okay, the next thing I want you to do is go to edit, then under project settings, and then go under the engine tab and select go under project, under the project tab, select maps and modes, and go under default maps and select in the editor startup map and game default map our test level. What this basically does is, when you start your Unreal Engine the next time, or this project the next time, the test level will be loaded as a default map. So you don't end up with an untitled map all the time. That's pretty annoying. And the game default map, this option basically uses the test level also as a default map. And when you press play, or if you compile it or launch it in standalone mode, it will use the test level as the default game map. Okay, that was the first thing. Now we will go down to the business. When you press play, you will see this our reticule we created. But the problem is, it's based on a widget, and widgets can't glow. You can't make your HUD glow, you can't make your reticle glow, you can't use any lighting information in our level for our widgets. So widgets can't use glow or any lighting effects or lighting whatsoever. And that can be pretty nasty for some people, because you might want to have a glowing HUD or maybe a glowing reticle or whatever you want. And yeah, well, widgets are not the way to go then for you. Okay, to change that, I have two different options how you can do it. So the first thing is we want to we don't want to use our curse reticle anymore based on the widget system. So here, go into edit up here, then under project settings, and then go under the engine tab under user interface, and then under our cursors or default cursor, select the reticle widget and select it and put it on none. This will basically get rid of our widget. Wonderful. The next thing I want you to do is create a different material. So we right click on our existing cursor reticle mat, select duplicate and type in reticle curve reticle underscore decoy. because the first method we will use is the decal system. And we will also rename this because it's not Reticle but Reticle, because I was a moron and I can't spell right. Okay, so now we have our cursed Reticle decal. Double click on our newly created material, and it will look like this. Change our material domain on the left panel here from user interface to deferred decal, and it is actually complaining. Material using the deferred decal domain need to use the blend mode model translucent. This saves performance. You would think these curved brackets or this need is just a choice that you actually are able to choose between these modes, and you don't absolutely need to use the translucent mode. But you are wrong. You absolutely need to use the translucent mode. It doesn't work with different things because it will complain all the time. So this these deferred decals will only work with translucent blend modes. So go to our left panel under blend mode and select translucent. Now, normally we will end up with this here, but we want it to glow. So right click and search for 3 vector and select constant 3 vector. A constant 3 vector is basically, well, it works like you have an X, Y, Z coordinate, just with RGB colors. So 255 is normally the maximum value, and 0 the minimum value. But in Unreal it doesn't work, a little bit different with the RGB values. So if you type in 255, it will just be red. But if you put in the number 1, it will still be red. So the RGB values are clamped or are ranged from 0 to 1. So keep that in mind. But we can double click on the 3 vector, or just select it and go and click onto the constant black here, and it will give us the color picker. You can give it every color you want, but it will still be black. You can fix it by just dragging this value up. It is just the brightness of our value. So we will go for orange color and click on OK. Now we need to right click and search for multiply. Select or connect this pin to the A pin and right click and search for constant, just a normal constant here. Go to the left panel, or select it, go to the left panel and type in 8. These things basically, or this glow effect will only appear when the glow value is over 1. So we choose 8 to make it glow a little bit brighter, and we will not connect it right now. First we will create another multiply node. Do it by typing in multiply, or you can just select the multiply node, press Ctrl C to copy the node, and just copy paste it here into our graph. So press Ctrl V to paste it, and now we will do the multiplying bit. So take our alpha mask, because we just want parts of our texture to be glowing, and connect it to the B value. Now we use this result, plug it into the A node, and we connect the 8, or our constant here, with our B value. And this resulting pin will be connected to the emissive color. What this here basically does is, it takes our alpha mask and it multiplies or combines these colors. This alpha mask with this color. So the result of these two multiplied will be put into the A and will be combined or multiplied with our 8 value. So it really glows, like you see here. The last thing we need to do here is plugging in some opacity. Because we have our alpha mask, we will take our alpha mask and plug it into the opacity and save it. If you don't do it, you will end up with all the parts of the texture and you will get black bars and just unwanted behavior. So just minimize and save all, and go into our El Diablo PC. Double click on it, and we are now on our player controller. Right click here and type in event begin play. Event begin play basically always triggers when you start a level or initialize your blueprint. So when your blueprint is created, this will fire as the first one. That's basically the gist of it, of event begin play. Now go to our get control pawn node, drag out from the return value and type in add decal component and select it. We will get this window, and the first thing you need to do is to tick this option. This will basically attach our decal component to the root of our pawn hierarchy. If you don't do it, it will automatically assign it to whatever it wants, and we don't want that. We will have it kind of as a component under the default root of our pawn. Okay. Connect event begin play with our add decal component, and then click on our add decal component. Now we can specify here a decal material. Just click on it and select our newly created curve reticle decal. Now the next thing you will experience is normally that this thing is locked here, and it will scale our decal sizes relative to each other. So if I put in here our value like 600, it will scale the y and z axis double the amount, because I had only half of the values in here in the x axis. So they are actually constrained to a certain ratio of our value. But because we want to have an equally sized decal, we need to click on the lock button and it will unlock our sizes. So type in 32, 32 and 32, and this is basically it, at least for this part. Why 32? Why not 600 or 800? The reason being is that when we go into our Reticle widget and click on our image here, we have it set in the image size on 32 times 32. So wonderful. We just took the dimensions of our widget here and passed them on the decal. So the last thing you want to do and which is the last thing of the part 1 in part 5, is that you drag out from the return value and you type in set world location and rotation. We want to rotate it based on the material it hits with our get hit result on the cursor by channel. So connect the event tick with the set world location and rotation node, and this end should be connected to the enter gate. Now go to the location here and connect it with our new location. And our new rotation will be made by our make rod Z. So just click on the normal here, or drag out from the normal, type in make rod, and we will use the make rod from Z. This would basically take the rotation, or it will take the normal it hits, which is basically some kind of tangent, where we extract the Z value out. So we create a rotation from our Z vector. And this will basically project our decal always on the right side of the mesh. So when you created it, plug the return value into the new rotation and save it. And now we try it out. We press play and we get this weird thing here, which is really weird. And that's because decals are actually dependent on rotation. So go to our El Diablo PC, click on Add Decal Component, and select up here in the rotation the y-axis and type in 90 degrees. This will basically fix our problem. Apparently not. So we will go back and okay, let's see if it works with an absolute rotation. Nope. Putting it back to relative rotation. Is it maybe the rotation? That's weird. That's actually pretty weird. Well, let's try set world location and use this instead of this node, and just connect it back. Okay, sorry for this bit. We delete the set world location and rotation, and instead we use from this pin here the set world location node. We will actually connect it with the event tick node here and put it into the enter gate node and put our new location in from our location node here. The problem with make rod from Z is that decals are dependent, like I said, on a certain transform and a certain rotation, and it works, but you will see it's kind of weird. It gets these weird stretches and such. This is a limitation of the decal system, because it can't really project on two surfaces at the same time. So keep that in mind. If you use decals, they will basically start to stretch and make weird shit. So, but they glow. And another downside of them is that you can't use opaque materials. It is always dependent on the translucent shader, so that's a downside too. But they can be very handy and very interesting to use. These are normally used for something like bullet holes, or if you have marks on an explosion or anything like that. Yeah, I think we will continue on our part 2 inside of our part 5. So see ya in the next one.